Okay, Algebra people, this is Unit 9, Notes 3, talking about simplifying rational expressions. So you need to be able to simplify a rational expression and find excluded values of rational expressions. So basically what you're looking at is something rational, so something kind of a polynomial, and try and figure out what are my excluded values. So a rational expression is just an algebraic function whose numerator and denominator are polynomials. So polynomials are like your x squared plus 2x plus 7. That would be a polynomial. So any value that makes the denominator of a rational expression 0 is excluded. So anytime you've got the bottom of a fraction equal to 0, that's bad because that means that you're dividing by 0 and you can't do that. So how to find excluded values? Set the denominator equal to 0 and then figure out what would that be equal to. So if I look here, state the value that makes each rational expression undefined. So I've got m minus 6. Well, if m minus 6 equals 0, I'm in trouble because that means I would be dividing by 0 and I cannot do that. So I want to add 6. So if m equals 6, I'm in trouble. So m cannot equal 6. Here I've just got one term, so 3x cannot equal 0. 3x cannot equal 0, so x cannot equal 0. So that's my excluded value. For here, for number 2, I need to factor this a little bit. Okay, so I need to draw my x or draw whatever. So I happen to know that that's going to be x minus 6 and x plus 1. So I'm going to set each part equal to 0. So x minus 6 equal to 0, x plus 1 equal to 0, and actually can't be equal to 0. So x cannot equal 6, and over here, x cannot equal negative 1. All right, and down here for number 4, last one, basically I've got two variables in there. So basically I'm saying x squared cannot be 0, or x cannot be 0, because if I take the square root to get rid of it, it doesn't matter. Square root of 0 is still 0. And then y cannot equal 0. So x cannot equal 0, y cannot equal 0. If either one of these is true, that makes my denominator 0, and that means I'm dividing by 0. So simplifying basically means eliminate anything in common between the numerator and the denominator. So looking here for number 1, or number 5 rather, so here's kind of the way I want to think about it. I want to break it up. I want to take 32 divided by 4. That's just a number. 32 divided by 4 is just 8. X to the 5th over x. So x to the 5th over x, if I subtract, so that's going to be x to the 4th. For y, so y is squared over y to the 7th. If I subtract that 2 minus 7, I get negative 5, which tells me it's going to be over 1 over y to the 5th. So my final answer here is going to be 8x to the 4th over y to the 5th. So for number 6, same kind of idea. I'm going to break it up. So I'm going to take 16 over 8. And then I'm going to take, so that's going to give me 2. If I take c squared over c to the 3rd, 2 minus 3 is going to be negative 1. So that means it's going to be in the denominator, so 1 over c. Lastly, b to the 4th over b, that's like b to the 1st, so 4 minus 1 would be b to the 3rd. So this is going to be 2b to the 3rd over c. There's your answer. So now, simplify everything. So basically, here's what I got to do. I got to factor the top, factor the bottom, and see what I can come up with. So when I do this, if I factor the top, factor out what's in common, I get 3 and then x minus 5. On the bottom, factoring that trinomial, draw your x if you need to. This is going to be x minus 5 and x minus 2. So cancel, cancel, because those two are the exact same thing. So I'm left with 3 over x minus 2. But x minus 2 cannot equal 0, so x cannot equal 2. So there's my solution. There's my excluded value. For number 8, same kind of idea, except I got to factor top and factor bottom. So factoring the top is going to give me x minus 7 and x plus 5. On the bottom, that's going to be x minus 7, x minus 2. So if I do that, cancel, cancel, x plus 5 over x minus 2. So my excluded value then, x minus 2 equals 0, x is going to equal 2. So x cannot equal that. So x cannot equal 2, and there's my solution. So Jenny has guppies in her aquarium. 1 week later, she adds 4 neon fish. So define a variable for neon fish and guppies, then write an expression that represents a fraction of neon fish in the aquarium. So we'll let n be the neon ones, g be the guppies. So the fraction of neon fish in the aquarium is going to go like this. So she starts out with guppies, then she adds 4 neon fish. So the number of neon fish is going to go like this. So that's going to be, the number of neon fish is going to be 4 divided by 4 plus g. All right, that's going to give me the neon fish. All right, that's the fraction. She added 4 neon fish, so 4 over 4 plus g. Suppose 2 months later the guppy population doubles. Jenna still has 4 neons and she buys 5 tropical fish. Write an expression shows the fractions of neons in the aquarium after the other fish have been added. Okay, so you have 4 neon fish, and then so on the bottom you're going to have all the guppies. You're going to have the 5 tropical fish plus the 4 plus the 4 neon. So that's going to be your expression. Okay, that's all I got. Come talk to me with questions.